Module 2, Section 8.3, Evaluating Trigonometric Functions. We can define the trig functions as ratios of the sides of right triangles. Here we see acute angle A is drawn in standard position and creates a right triangle. So we have the following right triangle based definitions of our trig functions. As you can see, sine is y over r as we defined previously, cosine is x over r, and tangent is y over x. In this triangle, right triangle, sine is the opposite side over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. And cosecant, secant, and cotangent are the reciprocals of those. So we see that we have the anagram SO for sine opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So to help you remember the definitions, just remember SO, TOA. So let's do an example. We want to find the values of the sine, cosine, and tangent of angle A here in this right triangle. So we identify that 29 is our hypotenuse. It's the side opposite our right angle. The adjacent side would be 20 here. And that's adjacent, so let me mark that here so we know the difference here. Our adjacent side. And our opposite side would be 21. So remember SOHCAHTOA. So we have the sine of A would be the opposite side over the hypotenuse, or 21 over 29. The cosine of A would be the adjacent side over the hypotenuse, which is 20 over 29. And the tangent of A would be the opposite side over the adjacent side, or 21 over 20. Angles that deserve special study are 30, 45, and 60 degrees. Let's look at a 30-60 right triangle. It has the following breakdown of sides: 1, square root of 3, and 2. 2 being the longest side is the hypotenuse, and its opposite our largest angle, which is 90 degrees. 30 degrees is our smallest angle, and the opposite side to it is 1, which is our smallest side length. And then the middle value, square root of 3, is opposite the middle angle, or 60 degrees. Now let's look at a 45-45 right triangle. The sides, since it's 45-45, this is an isosceles triangle, so these sides are the same, and we'll label them as 1. And then the hypotenuse would be the square root of 2. So we can see that in this case, if I was to try to find, let's say, the sine of 60 degrees, the sine would be the opposite, which would be square root of 3, over the hypotenuse, which is 2. If I wanted to try to find the sine of 45 degrees, I can use either angle, and I take the opposite side, which is 1, over the hypotenuse, which is the square root of 2, and I need to rationalize that denominator, so I'm going to multiply by the square root of 2 over the square root of 2, and I end up with the square root of 2 over 2. Here we see a breakdown of our special angles, 30, 45, and 60 degrees, and all 6 trig function values for them. Now let's look at cofunction identities. We have the following triangle. Notice that in this triangle, angle A and angle B are complementary. Which means that they add up to be 90 degrees. So A plus B is 90. Or we can solve this equation for B and have that angle B is 90 minus angle A. Now let's also notice that the sine of A, angle A, would be the opposite side, which is A, over the hypotenuse, which is C. Also, if we look at the cosine of angle B, then that would be the adjacent side, which is A, over the hypotenuse, which is C. So we see that the sine of A and the cosine of B are defined to be the exact same ratio. So the sine of A is equal to the cosine of B, which indicates that these are cofunctions. So then what that allows us to do is to say that the sine of A is equal to the cosine of B, and instead of using B, we're going to use our definition here of B, which is 90 minus A. So that both are written in terms of angle A. Similarly, secant and cosecant are cofunctions, as are tangent and cotangent. So we can write our cofunctions the following way. When they're measured in degrees, we write 90 degrees minus our angle. And when they're measured in radians, we use pi over 2 minus our angle. So let's do an example. For this one, we want to write the expression in terms of its cofunction. The cofunction of sine is cosine. So we have, this can be written as the cosine of 90 degrees minus 38 degrees 29 minutes. Now you're welcome to perform that calculation any way you like. Probably using the calculator is easiest, but we end up with then cosine of 51 degrees 31 minutes when we do the subtraction. Now let's find the cofunction of secant of pi over 5. Since we've now switched to radians, as indicated by the use of pi here, we use the cofunction of secant, which is cosecant, and instead of using 90 degrees, with radians we're going to use pi over 2, and we subtract our angle, which was pi over 5. So we're subtracting fractions here. If we find a common denominator, we end up with the cosecant of 5 pi over 10 minus 2 pi over 10, which gives us a value cosecant of 3 pi over 10. Let's look at reference angles. A reference angle for an angle theta, written theta prime, is the positive acute angle made by the terminal side of angle theta and the x-axis. Here we see our angle theta with its terminal side in quadrant 2. We end up with our reference angle theta prime written here in quadrant 2. Likewise, when the terminal side ends in quadrant 3, our reference angle is here. And here's another indication when our terminal side is in quadrant 4. The biggest thing to remember, and I'll write this in bold, you want to always use the x-axis to find the reference angle. Always. So let's look at an example. We want to find the reference angle for each angle given. Our first angle is 212 degrees. 212, if we were to draw it, has its terminal side in quadrant 3. So our reference angle is here. So we see that this is 212 degrees. And our side here is 180 degrees. So to find our distance here, our reference angle, we're going to take 212 degrees minus 180 degrees to find out what our difference is here. And we end up with a value of theta prime as 32 degrees. So our reference angle is 32 degrees. Now let's look and find the reference angle for theta being equal to 1032 degrees. Since this is greater than 360, the first thing we need to do is to find the smallest coterminal angle within the distance between 0 and 360 degrees. So what we can do is subtract 2 times 360, and we end up with 312. Basically what we want to do, if you're not sure how many times you need to subtract 360, just start subtracting. So we start with our angle, and we're going to subtract 360 once, and we can subtract it again before we get a value between 0 and 360, and that is 312. So now we can draw our angle, and we see that the terminal side will be in quadrant 4 for 312 degrees, and so our reference angle will be here. So what we have then, this side is 360, and to find this we're going to take 360 degrees minus 312 degrees, and we end up with 48 degrees for our reference angle. Now let's find the reference angle using radians of 7 pi over 6. If we convert this to degrees, we multiply by 180 over pi, and we end up with a value of 210 degrees. You're welcome to do this conversion if you're not sure which quadrant the radian degree measure will be in. So we know that 210 degrees has its terminal side in quadrant 3. So this is 7 pi over 6. Remember that instead of 180 degrees here, this side will be pi, and we need to find our reference angle, so theta prime will be 7 pi over 6 minus pi, so we end up with a value of pi over 6 when we subtract. Now let's look at special reference angles. We can find the exact trigonometric function values of angles with reference angles of 30, 60, or 45 degrees. So let's find the values of our trig functions for 225 degrees. We see from our picture that 225 degrees has its terminal side in quadrant 3, and if we took 225 minus 180, we end up with a reference angle of 45 degrees. This gives us, with our right angle here, a 45, 45 right triangle. So I've labeled our sides X, Y, and R, and remember that we had 1, 1, and square root of 2. But since we're looking at the coordinate plane here, we see that our X values are negative on this side, so instead of 1 we have negative 1, and our Y values are negative below the X-axis, so this is negative 1. And our distance here will always be positive, so you don't have to worry about the sign on the hypotenuse. So we want to find the sine then of 225 degrees. We are actually using the sine of our reference angle, which is 45 degrees, and so we'll do the opposite over the hypotenuse, which would be negative 1 over the square root of 2, and then we multiply by square root of 2 over square root of 2. So we have negative square root of 2 over 2. The cosine of 225 degrees is going to be done similarly. So we have the adjacent side will be negative 1 over square root of 2. So we get the same value, negative square root of 2 over 2. And the tangent of 225 degrees would be the opposite over the adjacent. So we have negative 1 over negative 1, which is a value of positive 1. And to find the other trig functions, we simply take the reciprocal of each of these. So to find the trig function values for any non-quadrantal angle theta, we have the following steps. First, we want to find a coterminal angle if our angle is not between 0 and 360 degrees by either adding or subtracting 360 as needed. Step 2, we want to find the reference angle, theta prime. Step 3 is to find our trig function values for our reference angle. And step 4 is to determine the correct signs for the values found in step 3. Now, this is laying out to use the table I previously told us about, cast, where we see that cosine is positive in quadrant 4. All trig functions are positive in quadrant 1. Sine is positive in quadrant 2, and tangent is positive in quadrant 3. You'll notice in the previous example, though, that I found our sines prior to finding the trig function values. Once I found the reference angle, I determined, based on where it was on the coordinate plane, what the sines needed to be on our special triangle. It's up to you which one you prefer to do first. So let's find the exact value of the tangent of 750 degrees. Notice it's greater than 360, so we need to find the smallest coterminal angle. We subtract 360 2 times, and we end up with a value of 30 degrees. 30 degrees is in quadrant 1, so we see that we end up with a triangle of 30, 60, 90. So our sides will be 1 across from angle 30, square root of 3 across from angle 60, and 2 across from our 90 degree angle. And all the signs are positive since we're in quadrant 1. So the tangent of 750 degrees is equivalent to the tangent of 30 degrees, which will be the opposite over the adjacent, or 1 over square root of 3, and we multiply by square root of 3 over square root of 3. So we have the square root of 3 over 3. Now let's find some function values using our calculator. We want to approximate the value of each expression. First, we want to take the sine of 38 degrees 16 minutes. So let's open up our calculator. First thing to do would be to make sure that we're in degree mode. So we press the mode key, arrow down, and hit enter on degree, and then clear. We want to take the sine of 38 degrees. So to put our degree symbol, we press second, apps, and 1. And then 16 minutes, we'll use second, apps, and 2. And we see that we get a value of approximately 0.619. Now let's find the secant of 10.135 degrees. Your calculator doesn't have a secant button, so we're going to have to use the fact that secant and cosine are reciprocals, and we do 1 over the cosine of 10.135 degrees. Now our calculator is already in degree mode, so we simply do 1 divided by the cosine of 10.135. And we see we get a value of 1.01585. Now let's find the value of the cosine of 3.8. Notice, since there was no degree symbol, this value is in radians. So we need to change to radian mode. But let me show you what would happen if we left it in degree. We did the cosine of 3.8 and then did second apps number 3 to put the R. That indicates that we want the radian measure. Now let's change our mode to radian and find the cosine of 3.8 without putting the R. You see that you get the exact same value, so either way is fine. Let's use our inverse trigonometric functions to find angles. We want to use a calculator to find an angle theta in degrees, and that's important. that satisfies the following. So we have, if the sine of theta is approximately 0.9677, then theta is the sine inverse of our angle. So we open our calculator. We want to be in degree mode. We do second sine for the sine inverse and type in our angle. And we see that we get a value of 75.4 degrees. Now let's use a calculator to find our angle theta in radians that satisfies the following. If the tangent of theta is approximately 0.25, then we find that theta is the tangent inverse of 0.25. And remember, this is in radians. So on our calculator, we're going to change our mode. We do second tangent of 0.25, and we get the following. Let's find all angles of theta if theta is in the following interval, 0 to 360 degrees, and the cosine of theta is negative square root of 2 over 2. Remember, using cast, cosine is positive in quadrants 1 and 4, so the cosine will be negative in quadrants 2 and 3. So to find one of our angles, we say that theta equals the cosine inverse of negative square root of 2 over 2, and we're using degrees as indicated by our interval here. So let's pull up our calculator. Make sure that we're in degree mode. And we'll do second cosine of negative square root of 2 divided by 2. And we see we get a value of 135 degrees. That angle is in quadrant 2, so we've taken care of this one. Now we need to find our possible angle in quadrant 3. Notice the reference angle is 45 degrees. So for quadrant 3, we would simply use 180 plus that same reference angle, 45 degrees, to get a value of theta of 225 degrees. Now let's find two angles in the interval 0 to 2 pi that satisfy cosine of theta being equal to the following angle. Since we've changed to 0 and 2 pi, we're now in radian mode. So on our calculator, let's change our mode to radians. Now notice that cosine is positive, and remember from cast that the cosine is going to be positive in quadrants 1 and 4. So we have that theta is cosine inverse of our angle. And we see we get a value in radians of 1.2. So now, since 1.2 is smaller than pi over 2, which is approximately 1.57, then this angle, theta, is in quadrant 1. So we need to find an equivalent angle in quadrant 4. So we'll take 2 pi and we'll subtract our reference angle, which would be 1.2. When we do the subtraction, we get a value of 5.083185307. So our two values would be 1.2 and about 5.08.